Force testers are machines that pull and compress products to the breaking point or near to it. These testers are used in labs and factories to test the integrity of products. The force tester verifies that the object has what it takes for its particular application. Force testers are built to pull and compress things. Here, the tester arm bears down on a pencil. It determines how much force can be applied before the pencil bends or breaks, and it displays the measurements on a screen. In the 1930s, basic force gauges were attached to cranes to measure a product's strength. But today's force testers are higher tech, with digital displays and computerized controls. Production starts with the steel base. The assembler screws brackets for the main computer board to it. He then installs the computer board using nuts called standoffs that raise it above the steel plate. This creates an airspace between the two, preventing electrical shorting. Throughout the assembly, the technician wears an electrostatic discharge band on his wrist. This arrests static electricity to prevent damage to the parts. He screws the motor drive board to the force tester base and moves on to the next parts. They include the power supply board, a mechanism to turn the unit on, and an emergency stop assembly. He routes the wires for the power switches and installs the push buttons. He connects a ribbon cable to the main circuit board. He connects the other end of the cable to the motor drive board. This allows them to communicate. And finally, he completes the power supply connections. Another member of the team now assembles a vertical support rail to an aluminum base. This rail is essentially the backbone of the tester. It will support the force arm and the track it moves on. He screws the track to the support rail. Using an alignment tool, he slides the shuttle into the grooves of the track and then confirms that the shuttle moves freely up and down. He's now ready to mount the force arm to the shuttle. He inserts a long threaded rod known as a lead screw into the force arm and fastens it to it. The lead screw will rotate to move the force arm up and down. He lowers an aluminum cover over the force arm assembly and secures it to the base. One side of the casing is open. He'll install an accordion-style rubber curtain to it later. Next, he threads a rubber belt around a pulley attached to the end of the lead screw. He installs the motor and wraps the other end of the rubber belt around the motor pulley. This motor drive assembly is what will turn the lead screw to move the force arm. He now mounts the base with the electronics to the force tester frame. He connects the switches for limiting the force arm's range of movement, and he installs an encoder on the motor to provide feedback on speed and power. He covers the electronics with a tough plastic casing. Next up is a slotted table. He clips a computer tablet to the tester. He uses an adjustable bracket for changing the screen's position during use. A force tester doesn't just bear down on things, it also pulls things apart. A technician conducts a pull test on a piece of nylon cord. He activates the force arm. The force arm pulls the cord as it's gripped at the base. The tester measures the peak force required to pull the cord apart, and the results are displayed instantly on the control screen. There are different force testers for different applications, but the purpose is always the same: to pull and compress objects in order to test their limits.